Hello, in this online lecture we're going to be learning about percent composition, also sometimes called percent mass, and it's a way for chemists to compare the mass of one element in a compound to the mass of the entire compound. So let's start with percentages in general. Percentages are always a comparison of a part to a whole. So a percentage equals some part of something divided by the whole of that thing times 100. It's a ratio of a part to the whole times 100, and that's where the word percent comes from, like per, and then cent means 100. So this means per 100. Century is 100 years, right? A penny, there are 100 pennies in a dollar. That's why the pennies are called a cent. So this means per cent means of 100. And so basically a percentage is a way to take a ratio between two numbers and then make that ratio out of 100. And it's useful for comparing things. So what's percent composition? Well, that's when you take the concept of percentage and you apply it to a compound. So let's say we have a compound, a really simple compound like sodium chloride. Sodium chloride, which you should be able to do the name and the formula. You know, whether I give you NaCl or sodium chloride, you should be able to figure the other one out at this point in the course. So let's say I wanted to know what percentage of sodium chloride was sodium. So I want to find the percentage sodium in sodium chloride. So basically what I'm saying is that whenever you have sodium chloride, what percent by mass of that is sodium? Well, a percentage is a part divided by a whole. And so what we're going to do is we're going to use molar masses here. I'm going to need the molar mass of sodium because that's the part that we're interested in, that we want to find the percentage of. And I'm going to need the molar mass of sodium chloride because that's the whole. And a percentage is a part divided by a whole. So I need to activate my periodic table and then take a peek at it. I'm going to scroll down here a little bit. It looks like sodium's mass is 22.99 to 2 decimal places. So sodium's molar mass is 22.99 grams per mole. And if I come over to this side of the periodic table, it looks like chlorine's molar mass is 35.45. So chlorine is 35.45 grams per mole. And so to find the molar mass of sodium chloride, I just have to add those two together. So 9 plus 5 is 14. I get 14 again. That's 8. And this is 5. So the molar mass of sodium chloride is 58.45 grams per mole. That's awesome. Now, we're trying to find the percentage of sodium chloride that's sodium. So I'm using colors to help make this a little bit more obvious. Percentage is a part divided by a whole. And for this problem, for this situation where we're trying to find the percentage sodium in sodium chloride, the mass of sodium is the part that we're interested in. And then the mass of sodium chloride is the whole. So if I was going to set this up to try to calculate the percentage of sodium chloride, the percentage of sodium in sodium chloride would equal the part. So the part is sodium, the mass of sodium, 22.99 grams per mole, divided by the whole mass of sodium chloride, which is 58.44 grams per mole. And what have we learned about things that are the same on the top and the bottom of a fraction? They cancel out. So grams per mole is going to cancel out, and we don't even have to worry about that anymore. All right, so that equals, that one I'm not going to do in my melon, so I'm going to pull a calculator over here. So 22.99 divided by 58.44 equals, whew, now since these numbers had 1, 2, 3, 4 significant figures. I'm going to use 4 significant figures. So I'm going to say 0. Oops. Hold on, I'll bring that back real quick. Come back. Okay, so I need 0.3934. See, with rounding rules, 393, and then that 3 becomes a 4 because it's followed by a 9. So I'm going to need 0.3934, and close that now. 0.3934. But we're not done yet because we have to multiply by 100. So I'm going to just carry it, we're out of room this way, I'm going to carry it down here. So 0.3934 times 100 equals 39.34%. So sodium chloride is 39.34% sodium. And that's how you find the percentage composition of an element in a compound. Now, compounds can get much more complex than that. So let's kind of scroll down past our periodic table here, and I'll do another example that's a little bit more complicated. Let's say I had copper sulfate. Now, there are several parts in copper sulfate. There's copper, there's sulfur, there's oxygen, there's sulfate, and we might be concerned about the percent composition of any of these. So just to show you that it can work this way, let's say I want to know the percent sulfate in copper sulfate. All right. So we have to find the part that we're interested in, and for this problem, that part is sulfate. And then we have to find the mass of the whole thing, of all of copper sulfate. So let me come over here. Let's start with sulfate. Sulfate is a sulfur and 4 oxygens. So I'm going to bring my calculator back really quickly. I'm going to need that in just a second. And let's go back up to the periodic table. And I need the molar mass of sulfur to 2 decimal places is 32.06 grams per mole. So 32.06 grams per mole. And I'm going to go back up here, and oxygen is to 2 decimal places, it's 16.00, but I have 4 of those. So I need 16 times 4, and that's 64. So 64.00 grams per mole. Now if I want sulfate, I have to add that up, and I'm going to need sulfate for my problem. So I'm going to add those two together really quickly. I don't need the calculator for that, so I'm going to get rid of it. And I get 6069. So the sulfate, and that's sulfate, SO4. The sulfate's molar mass is 96.06 grams per mole, but there's one more thing in copper sulfate, and that's copper. So back up to the periodic table, copper's molar mass is 63.55 to 2 decimal places. So 63.55. 63.55. Now I have to add those together, and that'll give me the mass of copper sulfate, right? So 11, 6, 9, 15. So the molar mass of copper sulfate is 159.61 grams per mole. All right, so why did we do all that math? We were trying to find the part and the whole that we're interested in. This is the sulfate. This is the part that we're interested in of copper sulfate. That's the mass of the part. And then the mass of the whole copper sulfate is right here. All right, so percent composition, it's the part divided by the whole times 100. The part divided by the whole times 100. So let's go back down here. The part, in this case, is sulfate, and it's 96.06 grams per mole. And the whole, in this case is the whole mass of copper sulfate, which is 159.61 grams per mole. All right, so I'm going to divide those two and find out the ratio that I get. Let me bring the, if I can here, let me bring the calculator back. Here it is. Whoop. All right, I got to clear that out. Get out of there. 96.06 divided by 159.61 equals. And since I have 4 significant figures on the top, there's 5 on the bottom, but I'm going to go with 4 for this answer. So I get 0. Of course, it disappears. It did that to me last time too. 0.6018. And the grams per mole cancels out. And then the last step is to multiply that by 100. So I get 60.18%. So that's our final answer. Copper sulfate is 60.18% sulfate. And that's about as complicated as it's going to get for this class. So as always, if you have any questions on how to do percent composition or percent mass, ask them in class. Thanks for watching.